Hello everyone. Welcome to the second part of this series called cryptocurrency. In the first video, we talked about why cryptocurrency exists. In this video, we are going to explore what is a blockchain. In the first video, we talked about creating a record book which will be having all the transactions, which is called as ledger, and that record book only is called as the blockchain. In this video, we will learn how do we create that blockchain which everyone can trust, no one can change it, and it doesn't need someone in charge. Let us understand what is the problem with the normal record books. Imagine a school where a teacher records student grades in a notebook, and suppose he writes that Ram got 85 in mathematics. Someone erases it and rewrites that Ram got 95 in maths. So how do you know what was originally written? So this is the first problem. The second problem can be if someone stole that notebook, all the record will be lost. Another problem can be that if only the teacher is in charge, he can refuse to show it to you. He can change the entries. He can lose that record book. So how do we create a record book that cannot be changed secretly, which cannot be destroyed, and no one person controls it? The simple answer for this is the blockchain. Let me start with the simplest possible explanation for this. It is like chain of boxes where each box contains some information and each box is connected to the previous box. If you break one of the connection, everyone can see it. But the clever part is how these parts are connected. They are not connected with some glue and all, rather they are connected with mathematics. So let us understand this step by step. The first step is what goes inside each box. Each box is called as blocks. It contains, for example, as you can see here, the block number 1, it contains the transactions, it has the timestamp, and it also has a link to the previous block's fingerprint. Since it is the first block, so there is no previous block here. And each block has its own unique fingerprint. Fingerprint means what? All the messages or the transaction, whatever we have, we apply hash function to each of the message, and that hash function for each message generate a hash which is called as the block's fingerprint. As you can see the code here. The second part is the mathematical fingerprint which I talked about. That is the hash which is assigned to each of the block. Now let us understand how does the hash works. Imagine it is just like some magical formula, I would say. It is denoted by capital H. Like we have all have studied about function, it takes some input values and gives some output values. Here H is a function which takes any data, and for that data it assign a unique code. For example, if we have the message Alice pays Bob $50, so if we assign hash function to this message, it will give us a code. You can see here that is hashtag A1B2C3D4. Now if you change the message from Alice pays Bob $50 to Alice pays Bob $51, you can see the whole output of the hash function gets changed. It is completely different now. So by changing one letter, or if you change the case from uppercase to lowercase, also in that case the hash function changes the output. So whatever you do with the original message, if you change even if a single change is there in the original message, the complete output gets changed. Like you can see here, the sum of the properties of the hash function, like if we have the same input, then only we are going to get same output always. But if you change even a single digit or a single letter, the whole output will get changed. And the best part about hash function is that if I tell you a particular hash, if I give you the output, you cannot figure out what was the input message. So that's the most beautiful advantage of using hash function. And one another unique property is that whatever the size of the input you give to a hash function, it will always generate an output which will be having a fixed size. Like you can see, for example, here we have a message hi, we apply hash function, we are getting 16 character code. Instead, if we have some other message like entire Harry Potter book, it is a message which contains more number of letters as compared to the initial message hi. But if you apply hash function to this message also, you are again going to get 16 characters code only. So that's another advantage. Any input size you give, you will always going to get a fixed size output. In real mathematics, the actual formula which is used in Bitcoin, it is called as SHA-256. It is based on cryptography, which we will explore in the upcoming video. For example, if you have the input message as hello, what is the output message? It contains 256 digit or a combination of letters, as you can see here. That will be the mathematical fingerprint for the message hello. And if there is a tiny change, the whole output gets changed. Now, why this is important? Because we know that in real life also, each fingerprint is unique. And that is the only proof that nothing has been changed. Correct? For example, if you have written some original essay by yourself, so if you apply hash function to this, you will get a particular fingerprint. Correct? And if someone modified your essay, then the whole output will get changed and the teacher will immediately know that this is not the original essay. So this is how the hash function works. Let us move to the next part, which is how we connect the first block to the second block, then third block, how these blocks are actually connected. We have seen just now that each blocks contain the fingerprint of the previous block. For example, this is the first block. We have the data like Alice sends money to Bob. Since it is a first block only, so there is no previous block. And for each block, we have a fingerprint. For this block, we have a fingerprint like hashtag A1B2. Now, for block 2, it contains the data that Bob sends money to Charlie. Now you can see here in under previous section, it is written the fingerprint of the previous block. And for this current block 2, the hash is or the fingerprint is hashtag C3D4. So this is how the blocks are connected. Similarly, for block 3, you can see that it contains the fingerprint or the hash value of the previous block. So this is how we create an unbreakable change. Now the last part is why you can't change the history. This is the magic of the blockchain and the power of mathematics as well, I would say. Now, let's see what happens if someone tries to cheat. Let's create a scenario like block 2. Originally, we saw that it has a message that Bob sends Charlie $50. Now, if someone wants to change this message to Bob sends Charlie $5,000. So again, the message has been changed. So basically, they have changed block 2. So initially, block 2 was having these three things: the data that Bob sends Charlie $50, and it was having the fingerprint of the previous block and the fingerprint of this block 2, which is hashtag C3D4. Now, since the message has been modified from $50 to $5,000, it will still contains the fingerprint of the first block, same as it is, but now for block 2, the hash will change. You can see here how from C3D4, it got changed to Z9Y8. So now block 2 hash will be hashtag Z9Y8. Now, what will happen if the fingerprint of block 2 gets changed? In the next step, we'll get that block 3 will break. Because you see, block 3 contains the data that Charlie sends Dinah $30. And it was having the fingerprint of the previous block, which was C3D4, but now it has been changed to Z9Y8. And E5F6 is the fingerprint of this block 3. So the fingerprint of the previous block 2, which is contained in block 3, is now changed. So block 3 will say that the previous block hash should be C3D4, but it is now Z9Y8. So from here we will come to know that the chain is broken and everyone can see that something is going wrong. So what the cheater will do, the cheater will have to fix block 3. Now if he goes to fix block 3, what he will change? He will update the fingerprint of the previous block 2 in block 3 and he writes Z9Y8. But wait, if you change the previous field, you can change the data in again in block 3. So now what will happen? Block 3 will have a new fingerprint now, correct? So it gets a new hash value, which is a fingerprint only. And you can see that it has been changed to M1, N2 instead of E5, F6. Again, we will see that block 4 will break. So the teacher will have to fix now block 4, then block 5, then block 6 forever. This effect of changing block 2, which leads to breakage of block 3, then again fixing of block 3, then block 3 hash will change, then again block 4 will change. Again, you have to fix block 4 and you keep on doing this forever for all the blocks. This effect is called as the cascade effect or the avalanche effect. One small change you did in block 2 and it creates an avalanche that breaks everything after it. So after block 2, you'll have to change each of the blocks. Now let us understand why this actually works mathematically. The first problem is the computational difficulty. Let's say you have 1000 blocks, and we will learn in the upcoming video on crypto mining that each block takes about 10 minutes to calculate. You have to start rewriting history from block 2. So out of 1000 blocks, you will have to make change in 998 blocks, and each require 10 minutes. So how much time you need? You will need at least 7 days to do this correction. But the next problem will be what? If you spend 7 days recalculating, the network will add new blocks. In 7 days, how many blocks will get added? Let's consider 6 blocks are being added per hour. So in 7 days, we will be having 1008 new blocks. So you are now more behind than where you started. That's the first problem. Second problem is the network speed. To successfully rewrite history, you need what? Your computation speed should be greater than the entire network computing speed. What does that mean? If a network has 1000 computers and each doing 1 million calculation per second, so what should be your network speed? It should be 1000 times 1 billion, which is 1000 times 1 million, which is 1 billion calculation per second. So to beat them, what you need is your speed to be greater than 1 billion calculation per second. Now, let us see how this is going to cost you heavily. If each computer cost $1,000 and it uses $100 per month in electricity, so what will be the cost for you? It will be it will be $1 million for hardware plus $100,000 for electricity, and even then also you will be having just a 50% chance of success. This is the second problem. Third problem is the security grows exponentially with each block. Let's say if you want to change a transaction that is 6 blocks deep, so what will be your probability of success? It is calculated by your power divided by the network power raised to 6. So let's say you have 40% of the network power. Whatever is the total power required, you have just 40%. So your probability comes out to be 0.4%. For 30% of the network power, you will be having probability 0.07%. So the deeper the transaction, that means more number of blocks if you are having, the more secure it becomes. So this is the importance of blockchain, and it is made sure that everything is working efficiently without any cheating being involved is made sure by mathematics. So what is a blockchain? It is just a chain of blocks which is connected by mathematical fingerprint. One thing you should remember that the blockchain doesn't prevent you from changing the history. You can change it, but it makes changing history so expensive and obvious that you will think that it's not worth trying only. So this is how blockchain works. Thank you for watching the video. The next video we are going to explore is how we assign these fingerprints. That means we'll explore what is a hash function.